Okay, what we're going to be looking at now is why cells divide, and then we're going to begin looking at the cell cycle. Now, this is a really good video, so I'd like for you to stop at this point and watch this video. This is Mr. Walkenfeld, and I use a lot of his videos. He does a lot of singing, but this is him just straight up sharing information, and he does a really good job describing um, visually why cells divide, which is a limit based upon surface area to volume ratio. So please watch this video. It is very beneficial, and then come back to me. So why cells divide is scoops. Why cells divide is because cells are limited to surface area to volume ratio. So I'm just really quickly going to sneak into Mr. Walkenfeld's video. And if you look behind him, this demonstration that he does, and he uses this razor blade and it gets off of very close to his fingers and it makes me nervous. But the reason why is this surface area, and I'll just mention it while we're kind of looking at it. The surface area, which is like the cell membrane, does not grow at a fast enough rate compared to the growth of the cytoplasm and all the materials inside of the cell, which is the volume of the cell. So the reason why cells must divide is because at a certain point, it really is divide or die time. So the surface area does not grow as fast as the contents of the cell. And you can see in this picture here, three different versions of cells, very similar to what Mr. Walkenfeld did. But if you notice, somebody did the calculations of math for you. So they did the surface area of each of these cells, the small one, the medium size, and the large one. And you can see the nucleus in the middle. And how it seems as you go through each picture, the small one, the nucleus is like right there. The second one, the nucleus is a little bit farther away from the outside. And for the third one, look how far in the nucleus is. Like, goodness, I hope we don't really need to get anything to the nucleus, or the nucleus needs to send out information. But the calculations, going back to the calculations, surface area, we can see is length times width times the number of sides, and that's been calculated for you. The volume is the length times the width times the height, and then when you put them together, it's surface area to volume. And if you notice, this really little small cell has a very large surface area to volume ratio, and as the cells get bigger, the surface area to volume ratio gets smaller. So herein lies part of our problem. So if we were looking at an actual cell and the needs of those actual cells, I go back to the nucleus, but look, there's also mitochondria. Over here looks like some random rough ER, some smooth ER, whatever it may be. But if you have a smaller cell, and your cells rely on materials to come in and out through the cell membrane, so in and out, in order to get those materials to where they need to go or to get products out, you have to have a small cell, which has a large surface area compared to its volume. Now, if we look at this cell over here, that is really, really big, and we see how everything is really spread out. So we have that same interchange there of trying to get materials to an organelle. It's going to take much longer. In fact, it might take too much time, and that cell could die because it can't conduct normal cell activities. So I put here, like I'm starving, but the opposite's also true. This cell has to get rid of waste that are produced. I mean, just think about carbon dioxide produced in cell respiration here. It has to be able to get out of the cell. So a cell could also die from a buildup of toxins. So as we look at the sorry, as we look at the surface area to volume ratio, it's kind of the opposite of where your brain wants to go. A small cell has a large ratio. A large cell has a small ratio. And we can also see with this cell here where the cell membrane grows slower than this volume, we could see that this guy could probably also burst. Now, when we're talking about the efficiency and how well this cell works, these little guys are going to work much more efficiently. This guy is going to be slow and sluggish and may not make it at all. So again, at a certain point, why cells divide, it gets to divide or die time. Um, Staying small is staying more efficient. Now, I like to use this other example, and my family does this all the time, and I tell them that I talk about them at school, so it's okay. Now, I don't know if it's a generational thing. It probably is, but all the older members in my family, they have to have everything screaming hot, and I mean screaming hot. Even if something was just prepared, if we're at a little get together, somebody's going to say, well, we probably need to pop that in the microwave just to heat it back up. And my goodness, it's the temperature of the sun. How much hotter do we need to have it? But um, this is how I look at it, and this is what I tell them. And they look at me like, you're a crazy kid, and we don't care. Nobody cares. But here goes. So if I go to a family dinner, or if I go out to a restaurant, let's say I order this nice hamburger, which is going to be really hard to eat with my mask on. But if I order this nice little hamburger, I don't want to eat it screaming hot. I don't want to burn my tongue. I don't want to burn the roof of my mouth. I just want to eat my food. So the first thing that I'm going to do is I'm going to cut it in half. And by doing that, you can see what I've done. I've increased the surface area. So now there's all this extra surface area of this hamburger now so it can start to dissipate the heat because sometimes heat can be a waste product, especially if it comes to some people eating their food. We don't want it the same temperature as the surface of the sun. So, what ends up happening with my family get togethers? So, let's say if we're eating a nice piece of chicken or steak or whatever it is, um, they'll start to cut it up, like cut up all their pieces. And then what I will tell them is that that's kind of counterproductive. They want their food screaming hot. They have to nuke it if it gets a little chilly, but then they take it and they cut it all into little smaller bits and pieces, which have a really high surface area to volume ratio, and they're going to cool down faster. Doesn't make sense, does it? But now you know.